It's a very versatile material with extremely exciting properties. By using these superlative properties either one by one or perhaps more interestingly in combinations, you can create many kinds of new applications that are not possible with other materials. So it's a very versatile material with extremely exciting properties. It can be used for many things. Well, one of the defining features of a surprise is that it's a surprise. We don't know when it comes and when it doesn't come. Of course, we can say that now that more people study graphene, we start to learn more about the properties of the material. So that could be an argument to think that maybe the era of surprises is on the decline. But on the other hand, the more we study, the more we learn, the larger our horizon. So that speaks in the other direction. It's very, very difficult to predict surprises, either their presence or their absence. That's sort of the nature of the thing. Graphene community is very diverse. We have people who come from many different areas of science and technology. It's very international. There are well more than 25 countries in Europe that have expressed interest in participating, or researchers in those countries have expressed interest in participating in our initiative. In particular for technological applications, that is very important, because graphene is a very new field. It has really only existed for about 7 or 8 years by now. And we need people who are very good at producing graphene, chemists or chemical engineers, people who are very good at making devices out of graphene, different kinds of engineers and physicists, and yet another layer of people who are very good at taking advantage of these devices, building new systems, be it new kinds of electronics or new kinds of airplanes or displays or new kinds of batteries for cars. So everybody needs to work together in order to create value, and that's one of the things that we focus on in this flagship, that we try to integrate the entire value chain, starting from the materials production, going through the component manufacturing, all the way to systems integration, make sure that everybody works together, and that way we can create the same impacts or larger impacts in a more efficient manner. The flagship gets people to work together. It coordinates research. Right now, there are a lot of research efforts in Europe, both on European level and national level. But all these efforts are independent of each other. What is discovered in one project is, to a large extent, lost after the project. People may publish a few papers, they may get a patent, but the key know-how is not transferred to other members of the community, and that slows us down. And that's a particular European problem in the corporate level, because our companies are segmented. We have companies that work on materials, we have companies that work on components, and we have companies that work on systems. Whereas some of our international competitors, they integrate, they work on all these functions, so they integrate the entire value chain by themselves. And then they can more easily transfer new knowledge on the materials level all the way to systems. And in Europe, in order to do that, we really need to work together. And that is what the flagship aims at, getting academics and industrial players to work together towards a common goal. And that's the difference it's going to make. I'm sure that graphene can revolutionize many branches of industry, just because it offers possibilities that are just not there with other types of materials. If you take one of the examples that is usually given as one of the first applications of graphene, that is flexible screens. You take your smartphone today, it has a screen that has to have optical functions. It's a screen, but it also has to react when you push the buttons, so it has to have electrical functions. There are very few materials that can do both these things, but those materials that we have now are rather fragile. You can't take your smartphone and drop it on the floor. It won't be so smart anymore. Whereas graphene is both flexible and it's very strong, so in that application alone, it offers many new possibilities. Another area is these lightweight composites, that if we can make material that is as strong as steel but weighs only 1% of the weight of the steel, you can see that that would revolutionize, for instance, car industry or airplane industry, and have great uses in other areas as well, say medical implants and so on. Right now, graphene is relatively expensive, although we need to differentiate between different kinds of graphene. There is the kind of graphene that consists of very small flakes, and that you can buy cheaply today, and that's material that is perfectly good for composite materials, for printable electronics, which don't need large area graphene. If you want to buy large area graphene, then it is expensive today, but it's only expensive because large-scale manufacturing has not started. If you think of any kind of first prototypes, they tend to be very pricey. But once the demand is there, the supply is there, we start manufacturing things on the industrial scale, it's quite cheap. And my personal view is that graphene, which is really nothing more than carbon, should not cost much more than newsprint, and it should be producible roughly the same way, 7-meter wide band of graphene coming at you at 160 kilometers an hour. But presently we are not there because the demand is not there and the supply is not there, and prototypes are expensive. That's a very difficult question because graphene and other related two-dimensional materials have such a wide range of possibilities that they will impact our lives in many different areas. One example, for instance, is the use of graphene in advanced batteries or supercapacitors. You think about today's electric cars. If you want to recharge them, you need to do that overnight in your garage, whereas with graphene, you can, or graphene batteries, you can probably recharge it in the time that it takes you to drink a cup of coffee. And that would enable the electric car revolution in a completely different way than we can see today. The main aims of the graphene flagship are to take graphene and other two-dimensional materials from their current state of raw potential to commercial applications and new products. And while doing that, create new economic growth in Europe, create new jobs, new possibilities for Europeans, both as investors and as employees. That's what we want to do. Of course, Europe is not the only place where we are investing in graphene. There is a very substantial investment in graphene in many Asian countries. And they have perhaps the advantage that they are more used to working together, either within the same company or at least within the same country. And with that, they are making great progress. So I think the flagship is Europe's opportunity to make great progress and make sure that we are not left in a spectator role when this new technology is developed, but we can harvest the fruits of these European discoveries and turn them into European technologies, economic growth in this continent. And I think that's an important aspect to keep in mind, that the world is not standing still in this area.